Hello friends, welcome to Physics with JP sir, and in this part of electric charges and fields, you will learn electric lines of force or electric field lines. So basically in this part you will learn these things. What are electric lines of force and electric field lines? Basically these two are the same things. Properties of electric lines of force, some very important diagrams which are useful for your exams, and of course at the end a few numericals. So let's start. Okay, so electric lines of force or electric field lines. What is this? What purpose? I mean, why do we have these lines? First of all, these are imaginary lines. These are not just some line drawn somewhere. These are imaginary lines, and these lines tell us the strength and direction of the electric field at that point. So, for example, I'll show you here. This is the diagram. You can see that this is positive charge and this is negative charge. Electric field line is coming from positive charge and it is going into negative charge. So basically, one thing you can notice that at this point, lines are close to each other, and at this point, lines are a little away from each other. So we can say that if this is A and this is B, so we can say that at A electric field is stronger and at B or at this point electric field is weaker. So denser the field lines are, stronger the electric field at that point. Second is tangent to these lines tell the direction of electric field at that point. So this is the purpose what it serves. So basically you know about the strength and direction of electric field due to these lines. These are imaginary lines, and these lines tell the relative strength. So you can compare the strength. Suppose that this point is P and this point is Q. So you can very easily say that electric field at P is stronger than electric field at Q because lines are closer, denser at P. One more thing, if you wanna find the direction of electric field at this point, so you just need to draw a tangent. This is the tangent. It means this is the direction of electric field at this point. What is the direction of electric field at this point? So simply you will draw a tangent. Okay, this is the tangent. All right, at this point, what is the direction of electric field? Simply you can draw a tangent. Okay, this, and this is the direction of electric field. Is it clear? Okay. Now the properties of electric lines of force. Electric field lines emerge from positive charge and they go into negative charge perpendicularly. Okay, so you can see here that electric field lines are coming from positive charge, they are going into negative charge, and it is happening perpendicularly. So this is perpendicular, they are making perpendicular, okay, perpendicularly, and they are going into the charge perpendicularly. Okay, this is 90 degree, perpendicular means 90 degree. Okay, second property, denser the field lines, stronger the electric field. We have already discussed this. Tangent to these lines tell the direction of electric field. We have also discussed this. No two field lines cross each other. I mean, two field lines cannot cross each other. Again, I want you to have a look at this, and you can see here that two field lines are not crossing each other. Okay, why? Now the thing is that why don't they cross each other? Okay, this is a frequently asked question. So my dear, if two field lines cross, suppose that there is another line and that crosses like this, what will happen at the point of intersection, where the point at which they cross, what will happen? There will be two directions of electric field. How? You know that direction of electric field is a tangent to the line. So if you go by this line, you will say that okay, the direction of electric field is in this direction. But if you go with this, keeping this line in mind, so you will say that direction of electric field is tangent to this line. So you can say that, okay, so you can see that there are two directions of electric field at one point, and of course which is not possible. We can't have two directions of electric field at one point. It means two electric field lines cannot cross each other. Okay, this is the reason I've written here. Now some important diagrams. So this is electric field lines coming out of positive charge. So this is a positive charge, electric field lines are coming out. Okay, so this is the diagram. So again, perpendicularly they are coming out. Alright, this is just one positive charge. Okay, now what if we have a negative charge? So this is a scene. In negative charge, electric field lines go into the charge. So you can see electric field lines are going into the charge. Alright, now we have a dipole. What is this? This is a dipole. Okay, two equal and opposite charges are separated by a small distance. So this is a dipole, and this is the structure of field lines, electric field lines in a dipole. So you can see here that electric field lines are coming out of positive charge and they are going into negative charge. I mean, if you want to draw, for example, if you have to draw, this is positive and this is negative. Okay, so what happens? Electric field lines come out of positive charge and they go into negative charge. So lines will be this. Okay, I'll change the color. So this is electric field line. Okay, and the direction of electric field is from positive, away from positive, and they go into negative. This, right? This. Understand? And here it's like this. So you can see now that they are coming out of positive charge and going into negative. So this is a dipole. Now if two positive charges, equal and opposite charges, are separated by some distance, so how will the electric field lines be here? Now, because these are positive charges, so electric field lines will emerge from positive charge like this. Fine. Now this, like this, like this, like this, like this. Fine. And same here, this. Okay, so if two equal and positive charges are separated by a small some distance, so this is the structure of electric field lines here. At this center point, this is called neutral point. There is no electric field here, and if you place a charge here, the charge will experience no force here. Okay, so it won't move. All right, fine. Now what if we have two negative charges separated by some distance, equal and negative? So this is negative charge, negative. Equal and negative charges are separated by some distance, and since these are negative, so lines go into the charge like this. Okay, now this, there is only one difference between, in between the previous one and in this one, that in this lines are going into the charge, and when we had positive charges, lines were going away. Okay, here similarly they are going into. Okay, very much similar to the previous one, but in that lines were going away from the charge, and in this lines are going into the charge. Alright, so this is the structure of electric field lines when two equal negative charges are separated by some distance. And finally we have a numerical. Now the question is, in this is from Resnick Halliday. In this figure, electric field lines on the left have twice the separation of those on right. Means electric field lines here, separation is twice as much as we have here. What does this imply? It means electric field at this point A is twice as much as B. Okay, closer the lines, more the electric field is. So if magnitude of electric field at A is 60, so magnitude of electric field at A means EA is given, and this is 60 Newton per Coulomb. What is the magnitude of force on a proton at A? So what is the formula of force? So at A, force on proton, you know the formula, that is QE. What is Q? 1.6 into 10 to the power minus 19. And electric field 60 is given. So it will be 9.6 into 10 raised to the power minus 18. Okay, and Newton, of course. But at B, electric field will be what? It will be half, because lines are not, lines are rarer, they are away from each other. So electric field will be just half. It will be 60 upon 2, because separation is twice as much as A. And okay, and now force on a proton at B will be just 1.6 into 10 to the power minus 19 into 30, and after solving we will get eventually 4.8 into 10 to the power. Okay, we have lack of space, I hope we manage. Okay, I'll change the color here. And it is 4.8 into 10 raised to the power minus 18 Newton. Okay, clear? So I hope you must have liked this video. Subscribe to this channel and make your friends subscribe to this channel and help this channel grow. See you in the next video.